Maximize z is equal to minus x plus 2y subject to the constraints x is greater than or equal to 3, x plus y is greater than or equal to 5, x plus 2y is greater than or equal to 6, x comma y is greater than or equal to 0. Let us graph the inequalities. Take given inequalities. X is greater than or equal to 0, x plus y is greater than or equal to 5, x plus 2y is greater than or equal to 6, x comma y is greater than or equal to 0. Write corresponding equations. First one is clear. X is equal to 3. We will get a line parallel to y-axis. In x plus y is equal to 5, when x is equal to 0, y is equal to 5. When y is equal to 0, x is equal to 5. In equation x plus 2y is equal to 6, when x is equal to 0, y is equal to 6. When y is equal to 0, x is equal to 6. Now mark the respective points. Two perpendicular lines on the graph paper represents both axes. X is equal to 3 is a line parallel to y-axis. Through points with coordinates 0, 5 and 5, 0. Draw a line. Write equation along with the line. Mark other 2 points with coordinates 0, 3 and 6, 0. Through these 2 points, draw a line. Now decide shaded region or visible region, how to shade. Consider coordinates of origin, that is x is equal to 0, y is equal to 0. When you substitute x is equal to 0, y is equal to 0, inequality x plus y is greater than 5 will gives 0 is greater than 5, which is false. Therefore, we should shade above the line x plus y is equal to 5. In second inequality, when you take x is equal to 0, y is equal to 0, 0 is greater than 6. Again, origin will not satisfy that inequality. Therefore, for this equation, just we have to shade above that line. Then we will get a common reason, which is unbounded. We suppose to take x is greater than or equal to 3, means right of that line. So this is the feasible reason. It is unbounded. So which are the corner points? Points with coordinates 3, 2, 4, 1, 6, 0. Let us calculate the values of z from the coordinates of corner points. Corner points. When x is equal to 3 and y is equal to 2, then z is equal to 1. When x is equal to 4, y is equal to 1, z is equal to -2. When x is equal to 6 and y is equal to 0, then z is equal to -6. Among these three values, one is the maximum value. When the feasible region is unbounded, then it is not possible to decide maximum or minimum value only on the basis of the values of z. Consider inequality minus x plus 2y, that is z, is greater than maximum value which we have got, that is 1. Corresponding to this inequality, equation is minus x plus 2y is equal to 1. Draw the graph of this line. When x is equal to 0, y is equal to 1 by 2. When x is equal to 3, y is equal to 2. Mark these 2 points. Through these 2 points, draw the line, dotted line. Take one point on x-axis, or you can take origin. When x is equal to 0, y is equal to 0, 0 is greater than 1. This is not true. Therefore, we have to shade above the line minus x plus 2y is equal to 1. As we have studied in the theorem, when feasible region is unbounded, we may get maximum or minimum value. Now in figure, half plane x plus 2y is greater than 1 has points common with the feasible region. To have maximum or minimum value, we should not have common points of feasible region and that half plane. But here we can easily find there are points which are common for both the regions. Therefore, z is equal to 1 is not the maximum value. Z has no maximum value. Question number 10. Maximize z is equal to x plus y. Subject to the constraints, x minus y is less than or equal to minus 1, minus x plus y is less than or equal to 0, x comma y is greater than or equal to 0. Let us graph the inequalities. Consider given inequalities and also write corresponding equations. First equation is x minus y is equal to minus 1. Take 2 points. When x is equal to 0, y is equal to 1. When x is equal to 1, y is equal to 2. From second equation, minus x plus y is equal to 0. When x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 1. Mark these points on the graph paper. Through these 2 points, consider given inequalities. For x minus y is less than or equal to minus 1, corresponding equation is x minus y is equal to minus 1. When x is equal to 0, y is equal to 1. When x is equal to 1, y is equal to 2. Corresponding equation of inequality minus x plus y is less than or equal to 0 is minus x plus y is equal to 0. When x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 1. Mark these points on the graph paper. Through these 2 points, draw a line. Through another 2 set of points, draw another line. Since equation is in the form of y is equal to mx, therefore it will pass through origin. Yes, now we have to shade. When x is equal to 0, y is equal to 0, from inequality x minus y is less than or equal to minus 1, 0 is less than minus 1, which is not true. Therefore, we have to shade above the line x minus y is equal to minus 1. Now let us take a point with coordinates 1, 0 in second inequality. Minus 1 is less than 0, which is true. Therefore, we suppose to shade below line minus x plus y is equal to 0. Did you get any common reason? No. Since there is no feasible reason according to the given constraints, therefore z has no maximum value. Exercise 12.2. Question number 1. Reshma wishes to mix 2 types of food P and Q in such a way that the vitamin contents of the mixture contain at least 8 units of vitamin A and 11 units of vitamin B. Food P costs rupees 60 per kg and food Q costs rupees 80 per kg. Food P contains 3 units per kg of vitamin A and 5 units per kg of vitamin B, while food Q contains 4 units per kg of vitamin A and 2 units per kg of vitamin B. Determine the minimum cost of the mixture. Let the mixture contain x kg of food P and y kg of food Q. Clearly, x and y both are greater than or equal to 0. We make the following table from the given data. Resources, food, types P and Q, requirements. Vitamin A units per kg in food P 3 units, 4 units, requirement 8 units. vitamin B in food P 5 units and in Q 2 units. Requirement 11 units. Cost per kg 60 rupees and 80 rupees. The mathematical formulation of the problem is minimize cost 60x plus 80y subject to constraints 3x plus 4y is greater than or equal to 8. That is vitamin A content. 5x plus 2y is greater than or equal to 11. That is vitamin B content. X comma y is greater than or equal to 0. This year, from here you may get questions. Let us consider inequalities. 3x plus 4y is greater than or equal to 8. 5x plus 2y is greater than or equal to 11. X, y greater than or equal to 0. Corresponding equation of 3x plus 4y is greater than or equal to 8 is 3x plus 4y is equal to 8. When x is equal to 0, y is equal to 2. When x is equal to 2, y is equal to 1 by 2. Corresponding equation of inequality 5x plus 2y is greater than or equal to 11 is 5x plus 2y is equal to 11. When x is equal to 0, y is equal to 11 by 2. When x is equal to 2, y is equal to 1 by 2. Draw two perpendicular lines to represent x and y axis. Mark the points. Through these points, draw a line. And again mark other 2 points. Through these 2 points, draw a line. Now we are supposed to set. Consider x is equal to 0 and y is equal to 0. They are coordinates of origin. When x is equal to 0 and y is equal to 0, inequality 3x plus 4y is greater than 8 implies 0 is greater than 8. False. So that is not the solution. So we are supposed to set above the line. And when x is equal to 0, y is equal to 0, 5x plus 2y greater than 11 gives 0 is greater than 11, not correct. So for this line also we have to shade above the line. And x is greater than or equal to 0, y is greater than or equal to 0. So we supposed to shade right of y axis and right of above x axis. Therefore, shade region, that is a common sided region. Feasible region is what we can see in figure. The shaded region in figure is feasible region determined by the constraints. The feasible region is unbounded. Let us calculate the values of z from the coordinates of corner points. When x is equal to 8 by 3, y is equal to 0, z is equal to 160. When x is equal to 2, y is equal to 1 by 2, z is equal to 160. When x is equal to 0, y is equal to 11 by 2, z is equal to 440. Among these values, minimum value is 160 in two cases. Consider inequality 60x plus 80y is less than 160, that is the minimum value. When you simplify, you will get 3x plus 4y is less than 8. Corresponding equation is 3x plus 4y is equal to 8. When x is equal to 0, y is equal to 2. When x is equal to 8 by 3, y is equal to 0. Draw line from these points. Same line you will get. Okay. So when you take x is equal to 0 and y is equal to 0, inequality will give 0 is less than 160. So that is true. So we suppose to set below the line. Now we have to check whether points of this half plane are common with the feasible region. From the figure, no points of half plane 60x plus 80y is less than 160 and feasible region are common. Hence, minimum value of z is 160 at all the points on the line segment joining the points with coordinates 8 by 3, 0 and 2, 1 by 2. Question number 3. A factory makes tennis rackets and cricket bats. A tennis racket takes 1.5 hours of machine time and 3 hours of craftsman's time in its making, while a cricket bat takes 3 hours of machine time and 1 hour of craftsman's time. In a day, the factory has the availability of not more than 42 hours of machine time and 24 hours of craftsman's time. Number 1. What number of rackets and pads must be made in the factory is to work at full capacity. Second one, if the profit on a racket and on a bat is rupees 20 and rupees 10 respectively, find the maximum profit of the factory when it works at full capacity. Let the factory produce X rackets and Y bats. Clearly, X comma Y is greater than or equal to 0. We make the following table from the given data. Product, time taken, rackets and pads, time available. Time taken by machine to make rackets and bats 1.5. 3. Time available, that is 42 hours. Craftsman, time taken in hours 3, 1, and available time is 24 hours. Profit in rupees from rackets 20, bats 10. The mathematical formulation of the problem is, first one, maximize z is equal to x plus y, that is the production of rackets and bats, subject to constraints 1.5x plus 3y is less than or equal to 42. 3x plus y is less than or equal to 24. X comma y is greater than or equal to 0. Second one, maximize z, that is profit, is equal to 20x plus 10y, subject to same constants 1.5x plus 3y is less than or equal to 42. 3x plus y is less than or equal to 24. X comma y is greater than or equal to 0. Let us graph the above inequalities. Consider given inequalities 1.5x plus 3y is less than or equal to 42. 3x plus y is less than or equal to 24. X comma y greater than or equal to 0. Corresponding equations are 1.5x plus 3y is equal to 42. 3x plus y is equal to 24. From first equation, that is 1.5x plus 3y is equal to 42. When x is equal to 0, y is equal to 14. When y is equal to 0, x is equal to 28. From second equation, 3x plus y is equal to 24. When x is equal to 0, y is equal to 24. When x is equal to 2, y is equal to 8. Let us take two perpendicular lines to represent x and y axis. Mark the points which we have got from equation 1. Through these 2 points, draw a line. Mark points which we have got from equation 3x plus y is equal to 24. through these 2 points, draw a line. Now we have to decide which portion we have to set. When you take x is equal to 0 and y is equal to 0, from inequality 1.5x plus 3y is less than or equal to 42, we'll get 0 is less than 42, which is true. So therefore, origin is one of the solution of that inequality. When we take x is equal to 0 and y is equal to 0, in inequality 2, that is 3x plus y is less than or equal to 24, we'll get 0 is less than 24, which is true. Therefore, origin is the solution of that inequality. Then, for both the lines, we have to shade below portion. So, which are the corner points? Origin with coordinate 0, 0, A with coordinates 8, 0, B with coordinates 4, 12, C with coordinates 0, 14. The shaded region in figure is the feasible region determined by the constraints. The feasible region is bounded. Let us evaluate Z at corner points with coordinates 8, 0, 4, 12, 14, 0. When x is equal to 8, y is equal to 0, z is equal to 8. When x is equal to 4, y is equal to 12, z is equal to 16. When x is equal to 0, y is equal to 14, z is equal to 14. When x is equal to 0, y is equal to 0, z is equal to 0. Among these, maximum value is 16 at point with coordinates 4, 12. Hence, maximum value of z is 16 at point with coordinates 4, 12. Number of tennis rackets is equal to 4 and number of cricket bats is equal to 12. Second equation is z is equal to 20x plus 10y. When x is equal to 8, y is equal to 0, z is equal to 160. When x is equal to 4, y is equal to 12, z is equal to 200. When x is equal to 0, y is equal to 14, z is equal to 140. When x is equal to 0, y is equal to 0, z is equal to 0. Among these values, maximum value is 200. Therefore, maximum profit is equal to rupees 200.